Hello, today we're going to continue exploring the features that HistText provide in terms of analyzing named entities. What you see on my screen here is the first tab that we saw in the previous video, entity data. And now we're going to go to advanced analytics. As soon as you click on this tab, in fact, you will see that you have a warning. And this is related to the fact that the number of entities exceeds largely the limit that we have set of 15,000 entities. So this limit is not absolute. It is set as a matter of safety, because depending on the kind of computer that you will be using, if you have too many entities, this may crash your browser. So you will not have any problem, and you will have to restart from your query. Depending on the institution, the administrator may decide to move up and down this limit. As you can see here, in fact, we offer you three possibilities. Either to analyze a subset of the named entities, here 50,000. So it will take the first 15,000, just really logically the first 15,000, not more. Of course, in this case, where I have 45,000, you're losing quite a lot. The alternative is, of course, to go ahead and process all that we warn you about. That's why it's written risky with a red button. Now, most of the time, you do not need to analyze the entire subset. So you have different options to reduce the number of entities. One of them is, in fact, to go back to your query, click on Cancel and Refine Query. And for example, you may decide that you do not need the whole period. And so you will choose a shorter period, or you will divide. If you really want to have everything, you can divide the period into 2, 3, 4, so that you can process all the named entities in sequence. An alternative is, in fact, to refine directly the subset of entities. Here you can you have an option 3, which is filter by entity types. Click here, and then, in fact, instead of having all the entities, you can decide which entities you really want to include in your analysis. Let's say that persons are important to you, perhaps also organizations, and already you know that you have 13,377. So immediately it tells you how many you have. I think I will stay at this stage in this case, and I will go for this option. So now I have another button here that says Analyze Selected Types, 13,000. It will process this subset of entities. This is what we call advanced analytics, and you will get new window with various tabs that I will explain one by one. So as you can see, it takes a little time, but not so much time to process the 13,000 entities. So immediately you have a summary. So total number of entities, entity types, of course, only 2 here, number of entities on average in each document, unique ratio of these terms, and the strong pairs that appear in your corpus. Pairs mean words that are frequently associated. You can see here in the first chart the most frequent entities found in your subset. Here we have police, and if you mouse over like this, it tells you the number of occurrences, the number of documents, and the rate of frequency. All these figures have been normalized. It's not just absolute numbers, it's normalized over the total size of your corpus. In this part, you can see the distribution. It's not very useful in this case because we chose only 2. We have more organization than person. That's all that you can see here. If you were to have more, types of entity, then you would have a different pie chart. Now you can immediately click here also so that you have your top entities by type. So you can see that for person, it's Mr. or Mrs. Hazeland that appears, and then Wong and Lee and Wood and Chan and so on. For organizations, it's police, it's mixed court, it's government, provisional court. Remember that our corpus is based on a query about shopkeeper. So it tells you something already in terms of which organization seems to be dominant in this data set. Now, the next tab is relationship, and it means the co-occurrence of terms in the documents. So for instance, here we see that the mixed court often co-occur with Grant Jones, or Tokyo Marine Insurance with Nippon Fire Insurance Company, and so on. So you have these normalized entity pairs that appear together more often than expected by chance. It gives you some statistical significance about how words appear in text. You also have the terms that are most frequently the most connected terms in your corpus. So again, we have Hazeland, which is not just the top person entity, but also the most connected entity in your corpus. And Wong and police. Of course, these names like Wong, Li, Zhang do not tell you much because they have been extracted. Perhaps they appear like this in the text, or perhaps there was a first name that was not recognized. I do not know at this stage, but it's a way of exploring this. Here you have exactly the same thing as above, but presented in a different way. So again, you have the normalized entity pairs with statistically significant relationships and proximity weighting. That's how it's called. So mixed court and Grant Jones, you see that they co-occur 6 times. They appear in 6 documents. And this is the average distance of characters between them. And this is why this proximity score was computed and lists them as a significant pair. Here you can see the mixed court probably, and mixed, of course, it's the same thing. So there's something that's not somehow correct, but this is a statistical calculation. We can see these 2 societies, Tokyo Marine and Kwan and the mixed court, and so on. So this allows you to have a preliminary idea, not just of individual entities, but how they appear together in these different texts that we have found. The next step is distribution. So after filtering entities with a higher score of confidence, in this case, everything below 30% was eliminated. Then you have first your chart that shows you that, well, most of the named entities have been identified with a very high score, and then of other categories that are less, for which the algorithm is less confident. You have here the size of the entities in terms of numbers of characters. So that again gives you more technical information, but it tells you something about the type of entity that you have here. Most have, as you can see, between 5 and 9 characters. Last, you have diversity. That's the document with the highest entity diversity normalized again against unique entities by the total number of entities. This is abstract, but if you want to see what you have, again, you can click on the ID of the text. You can also click on the eye here, and then you have the term that co-occur and why they appear together. I do not have much diversity here. because I made the choice to retain only persons and organizations. If you had selected more entities, then of course you would have a different distribution. My point is only to show you what we provide in terms of elements of analysis of the corpus. This general distribution of named entities viewed from various angles. Then we have something called document analysis. So document analysis, in fact, is a chart. It looks like a matrix, and it examines the distribution of entities at the document level with a focus on both quantity and diversity to identify standout records within the corpus. So you have a normalized view, again, of entity usage across individual documents. And in the same way as before, you can mouse over on each of these dots. It gives you the ID of the document, the number of entities found, the number of unique entities, normalized ones, average confidence rate, and rate of diversity. If you want to click or you want to see the document, here you are. We have quite a number of entities despite my selection of only organizations and persons. Typically here we have, of course, the mixed code, the provisional, so two codes, and of course different people who have been presented before these codes. The right panel presents a high-quality documents list that ranks documents based on their entity diversity. So each entry includes, in the same way, an ID on which you can click, the number of unique entities, so here I have 2 only, confidence rate, and so on. So you can look at that from different angles. At the very bottom, you have another panel that tells you something about anomaly detection, by which we mean document with unusual normalized entity pattern. And again, I have to remind you that all of that is done automatically through algorithms. And so in this case, you would want to see why you have an anomaly score once you understand what this means here. Of course, I cannot give you an answer without looking very closely at the document, but once again, you have another feature that just warns you about an issue possibly in the documents that you have and how they've been processed by the algorithm. Patterns. Now, patterns detect, well, it's explained here, it detects sequential patterns of named entities within documents that reveal common phrasings or narrative structures or complex relationships between actors, in this case persons, and organization. So we have bigrams patterns, so police and Wilhelm, Roubaix and Portland Cement, mixed code and Grant Jones again, and they appear in one document, and the number here, in fact, gives you the number of occurrences of the bigram. And you have the same here for trigrams. So instead of 2, you have 3. So Young Tong and the Servants Union, Show, Bernard Show, shows, probably, of course, the same thing. Acme Foundry, Von Begray, whatever. You have OCR issues and provisional quote. So these are frequent associations of the same set of either 2 terms, bigram, or trigram. We also have more complex entity patterns for quadrigrams. It's probably less usual, but as you can see here, we found some of them. We found 2 in this case that co-occur twice in each case. At the very bottom, you just have a summary of the total number of bigrams, trigrams, and complex patterns. My last tab is the deep analytics. So what does it mean? The Deep Analytics tab provides a higher level of exploration to understand the documents within your corpus. It explores semantic relationships between documents using entity-based similarity measures, clustering, and network visualization. You can see here that you can play on different parameters. You have sliders. You can decide to change the threshold of similarity. If you decrease, then you will reduce your criteria and make it easier to find similarities. On the opposite, if you increase the threshold, you will be more demanding in terms of a similarity. In the same way, you can decide that you want to include at least 50 documents or 10 or more. It's up to you to decide which work for your corpus. And then in the same way, for clusters size, we by default we set it at 2, but you can also increase, and the more you increase, of course, the more demanding it becomes for obtain a visualization. You can just move this. As you can see, as I move the slider here, I lower the ceiling, then yes, immediately I can see a network of these documents, 3 of them here and 4 of them here connected through that one. In the same way as before, you can always go immediately to the text itself. If you really want to understand or you want to explore why it has been identified as a text that has a similarity with its neighbors, you can always jump from this graph to the text itself. As I said before, you can incorporate more documents. Of course, it becomes much more difficult to read, in which case, perhaps if you want to be more selective, you can increase the number of clusters that you want to have. And of course, you want to increase the threshold. If you keep a lower threshold, you will have a lot of results. If you put it at 30% like here, as you can see, we only have, in this case, 4 clusters, 4 groups of documents with similarity. If I change the layout, it will not be very different. Perhaps the most different one will be that one. It shows you exactly the same thing. They are rearranged differently, and you can see the relationships between each document, which one is connected to the other. Let me go back to this representation. Advanced entity analytics, in fact, provides you different ways to look at your documents, at the entities that have been extracted and found, and have different ways, different angles from which to understand what you really have and what the content through the named entities and through their similarities and so on, what this tells you about the nature of the data set. It doesn't come naturally. It's not obvious to make sense of all these graphs and statistics, but in fact, all you need is to take some time to explore, look at the documents themselves. Do not trust the visualizations or the statistics per se. They will always compute what they find in the text. But what they find in the text and what they associate may not always make sense, or they may have identified terms that are incomplete, as we have seen before, with Wong and Lee, that do not really tell you much. But in this case, you can always, again, go back to the text. And this is very important. I think that's for historians, but also humanists in general, in that with HistText, you can always navigate back and forth between the statistical analysis, the statistical visualization, and the original document, the original sources. You can also move between the data set and the individual documents. This is what really makes HistText a unique tool. In the next video, I will not present additional features. I will show you examples of what can you do once you have extracted all these elements, either the full text of the documents or the named entities, because then you can go one step further of beyond what HistText presents, which is limited to make you understand the nature of your dataset. Thank you for your attention.